I am Jia Liu. I am a faculty at the Kavli Institute for Physics, Mathematics of the Universe, or Kavli IPMU. My major background is computational and observational cosmology. So I use computers as well as telescope images to study the origin and evolution of our universe. So in the course, our universe, I will go over the whole history of our universe. So there's 5 questions Kavli IPMU members are trying to answer. So we have physicists, we have mathematicians, and we have astronomers. We work together to understand 5 questions. What is the origin of our universe? What is the fate of our universe? What is the content of our universe? What is the fundamental laws of our universe? And finally, why do we all exist? So in this course, I try not to only teach you the facts, but I also want to challenge you to think through of all these fundamental questions. So in the lecture, I will introduce some key concepts such as the Big Bang, dark matter, dark energy, galaxies, exoplanets, those are the planets outside of our own solar system, black holes. Also, I want to introduce you the tools that scientists use to do our research, such as programming language and scientific measurements and statistics. So by the end, I hope you not only enjoy the discussion, but also equipped with some useful tools. Kavli IPMU is a very international institute. Our members come from all over the world. So here we have a the map of the world, and we put a flag for each one of our members where they're from. So you can see that they spread out everywhere. So this is where Kavli IPMU is, in Japan near Tokyo. And here we also show the major experiments we are having here. So this is the Subaru telescope we have in Hawaii. It is 8-meter telescope observing our universe in the optical light. So you see a lot of galaxies. So this is a little toy version of the telescope. So while PFS on Subaru is observing galaxies, so this is rather late time of our universe. We also have another project observing earlier time of our universe. So this, you might not notice, is the LIGHTBIRD space mission. It's a mission that will be launched by JAXA, Japan Space Exploration Agency, and the IPMU will be leading part of the design and science for this space telescope. LIGHTBIRD will rather observe the cosmic microwave background, which is from the early universe, the first light we'll see. Combining observations like LIGHTBIRD and the PFS on Subaru, we can really have a full picture of the origin and evolution of our universe. So at Kavli IPMU, because the type of science we study is very diverse, sometimes we're trying to use some creative method to explain to each other and to everyone else what we're doing. So here is a demonstration of the recent Lego Day we had. So scientists came together and built using Lego blocks to build structure to demonstrate the science. So I'm gonna introduce some of them. So this is the PFS. This PFS is a galaxy survey at IPMU. This is the emission line galaxy spectrum. So here is the blue and higher energy, and this is green and yellow and red light. So this is the spectrum of one of the galaxies. Well, it's a fake one, but it's a demonstration. And here is the Lego version of the LIGHTBIRD space mission we're building. Okay, this is not Lego, but this is rather model, real model. And here you can see this is a LIGHTBIRD telescope that will be launched on a satellite. And then you have 3 little telescopes inside. I mean, they're not little, they're little here. And they will have a low frequency, medium frequency, and high frequency telescope on LIGHTBIRD. And here is what you can expect LIGHTBIRD will observe. It is the cosmic microwave background, the earliest light you can observe from the universe. So here you have red, blue, and the green, different colors. They represent different temperature in the microwave background. Okay, so from a real image of the CMB or cosmic microwave background, we expect to learn how did our universe begin? or the inflation. So here you can, I think the attempt is dark matter particle. So now we know that our universe is made of mostly dark matter, not luminous matter that we can see. So here people build a strongly interacting dark matter. So they're supposed to collide and scatter with each other. And here is Lego built by mathematicians, which I personally don't quite understand, but I was challenging them to teach us what is singularity. So this is singularity they built, but then you can also blow it up into a different structure. And finally, I think a very interesting thing, this is the dark matter and dark energy. So this is dark energy, the effect of dark energy, that the universe was small, and then because of the existence of dark energy, it started expanding, and the expansion get faster and faster. And within the universe, you can also see, I think, dark matter and galaxies. So I presume the black ones is dark matter, and then here the galaxies that they are merging with each other and their gravitational attraction. So all of these objects are the subjects of our class, our universe. So in summer 2025, I will be teaching a GUC course called Our Universe. So it's actually inspired by a book not written by myself, but written by my colleague at Princeton, Joe Dunkley. So during this course, I will try to introduce the origin and evolution of our universe. And also, I will try to help you to think, what is the content in our universe, and why do we exist, and how do scientists do our research? So for example, I want to show you something interesting. So this is a beach ball. You can play with it. Well, it's a little bit deflated. But this is an observation from a space mission called WMAP. It's on here. So it observed the sky, but not in the light that our eyes can see, but it's in the microwave wavelengths. So kind of like the microwave that you use to cook food. And this is what they see in the sky. So this is the oldest light you can ever see in our universe, the cosmic microwave background. Well, except for this one, this is from our galaxy. But then everything else you see is from very, very early universe. It's about 380,000 years right after the Big Bang. It's really short compared to the history of our universe, which is 13.8 billion years old. So by observations like this, now we understand quite well the whole evolution history of our universe. So during this course, I hope I can walk you through what we have learned already with all these observations. So I hope some of you will join me in the course Our Universe, and see you next summer.